Is the world a dream? Is everything around us an illusion created by some god? Is the universe a computer game? Are we just dancing puppets, obeying the laws of some computer out there in the universe?
Is this current experience our reality? Perhaps a more fitting question is, what defines reality? Could everything we perceive, experience, and witness in our entire universe be artificially created? Advocates of simulation theory not only entertain the possibility that we might exist within a simulation, but also posit that it is quite probable. The deeper we delve into the search for evidence, the more compelling indications emerge. In this episode, we'll explore the reasons behind this perspective. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. 12 millennia in the past, humanity initiated the process of molding its environment, establishing the foundations of civilization. Fast forward to the present, and we find ourselves deeply immersed in the construction of virtual worlds. Is it conceivable that an advanced civilization, potentially eons ahead of our own, has orchestrated the ultimate simulation, surpassing our understanding? Donald Hoffman, a cognitive psychologist and acclaimed author in popular science, challenges conventional viewpoints on reality, space, and time. Hoffman posits that our perceived world may not align with true reality. Anchored in the principles of natural selection, he suggests that our inherent intuitions might be misleading. Despite the common assumption of accurate perception of reality, Hoffman argues that our evolved perceptions are finely tuned to essential truths for survival. He questions the prevailing belief that the moon, tables, chairs, and other entities exist independently of observers. Evolution by natural selection, he contends, implies that our language and perceptions, rooted in space, time, and physical attributes, may inadequately capture any objective reality. Thus, a profound choice emerges between embracing the well-established scientific theory of evolution by natural selection and adhering to our intuitive beliefs in the fundamentality of space-time and objects. Might be a mere illusion is not a novel concept. Ancient Greek philosophers, such as Plato, contemplated the nature of reality. Fast forward to the present day, and this age-old contemplation has transformed into a modern hypothesis, fueled by advancements in computing and digital technologies. The simulation hypothesis, born from these advancements, opens a cosmic door to a myriad of questions that challenge our understanding of existence, consciousness, and the very fabric of reality. Delving deeper into this cosmic conundrum, recent scientific insights introduce a new dimension to the simulation hypothesis. What if the fundamental laws of physics governing our universe are not just rules but algorithms in a grand cosmic program? Could we, as inhabitants of this universe, ever discern the digital nature of our existence, or are we destined to live unaware within the confines of our programmed reality? In this simulated universe, physical laws function as algorithms, and our experiences are generated by computational processes within an advanced system that could potentially achieve immortality. While speculative, this theory has captivated both scientists and philosophers, sparking both fascination and skepticism. An analogy to clarify this concept involves playing a game like Grand Theft Auto remotely with participants from different parts of the world. Each player perceives a red Porsche in their unique instance, yet the underlying reality coordinating these perceptions is a complex system akin to a supercomputer. This metaphor suggests that space-time is analogous to a headset, and beyond it lies an intricately complicated realm that is as complex, if not more so, than the supercomputer coordinating our shared reality. The sophistication of the headset is a testament to its advanced technology, but the true powerhouse lies in the supercomputer, an incredibly potent entity. Similarly, when it comes to space-time, it serves as our headset, and gazing beyond it reveals a realm of much greater complexity. In a sense, the scientific exploration thus far has focused solely on our headset, delving into the intricacies within space and time. The tools developed over the past few centuries, including experiments and refined mathematical theories, have enabled us to study what we believe to be objective reality, essentially our headset. Now, equipped with these tools, we are on the cusp of taking the first step beyond space-time, venturing into the exploration of structures beyond space-time and their projections back into it. From this perspective, considering objects in space-time as the fundamental reality may seem limited. Some scientists anticipate that in the coming decades, detectable glitches or patterns may betray the simulated nature of our reality, if indeed it is a simulation. However, uncovering such anomalies poses a formidable challenge, given the evolving nature of our understanding of physics. A recent study introduces a novel law of physics, the second law of infodynamics, supporting the theory of a simulated universe. This law, centered on the concept of entropy as a measure of disorder, posits that information entropy must either remain constant or decrease over time. The intriguing consequence is the optimization of information content in the universe, hinting at the possibility that the entire universe might be a meticulously crafted simulated construct, a grand computer program operating on an unimaginable scale. Quantum mechanics provides compelling evidence for the notion that our universe could be a simulation. Take, for instance, the double-slit experiment, a cornerstone of quantum mechanics. This experiment reveals that particles such as electrons and photons exhibit characteristics of both particles and waves when unobserved. They appear to traverse two slits simultaneously, creating an interference pattern typical of waves. Yet when observed, they conform to particle behavior passing through only one slit. This peculiar behavior, seemingly at odds with classical physics, aligns with the simulation theory. In a simulated universe, the rules are not bound by our traditional understanding of physics. The observation effect in the double-slit experiment may resemble a rendering feature in a simulation where elements fully manifest only when observed, mirroring how video game environments are detailed only when the player's character directs attention to them. Thus, the assertion that local realism is false gains credence. Local realism posits that objects in space-time, such as a proton, possess definite values for their properties like position, momentum, and spin, even in the absence of observation. It also asserts that these objects exert influences that propagate at speeds no faster than that of light. However, substantial evidence suggests that local realism is likely untrue. This raises the question of whether the falsehood lies in the concept of locality or in realism itself. One argues that realism is the facet in question, asserting that a particle lacks inherent values of position, momentum, or spin when unobserved, and these properties are essentially created as elements of a headset when observed. This perspective aligns seamlessly with phenomena such as the double-slit experiment. Regardless of whether we exist within an intricate simulation, these scientific inquiries usher in a fresh understanding of our universe. They prompt us to reconsider the very nature of reality and our position within it.